Good. Near photographic memory. Read something, anything. 5 years, 10 years later, she can just come up and spew it back. And I came to understand that that is an awesome trait to have. It's also sometimes a little bit of a challenge. It's a difference because she can, right? Eye glazing detail. Yeah, I can solve this as part of my community. He's the one that doesn't have that color. Dog might be smarter than me too. She's she definitely knows exactly to the second when dinner time is, but in the morning, her face will be right here, waiting for me to wake up. Or do you want to talk to me? But here was the thing with that. She knew what to do if it was out of the book. If there's something that's outside, and good, I talked about those knots. We were doing a hike on GDT a few years ago. We were hiking, and we were in the tent, and it was like 2 a.m. And a porcupine came in and immediately went for the sweaty part of the strap, right? And in 2 seconds, had chewed through this thing. She was lost. No idea what to do because they didn't have a knot for porcupine chewed straps on backpacks 2 days away from the front country. There was no page on that ever. So she had a problem. But I came to understand we do think totally different. I don't think about details. Like, so for today, she was like, well, what's your thing this morning? I'm like, I'm going to look it up now. And I'll show up there on time, but I don't need to know that ahead of time. So I'm a lot about the process and how things work. We have sort of what we describe as above the belt jobs and below the belt jobs. If something is broken, I'm the guy that fixes that. If you, yeah, money, anything to do with money ever, she's the one that works with that. And honestly, we are going to talk about Wireshark eventually. But kind of the point of this is that I think it's quite critical to think about this in terms of security and in terms of IT. So my background, I'm a pretty fierce troubleshooter. If something doesn't work, dog with a bone, I don't stop. A lot of it has to do with kind of this difference in approach. And so Wireshark is a great tool for this. I teach at SAIT. I teach in the networking program there, or what used to be the networking program. And it's a fantastic tool for teaching students, so we use it all the time. It really shows you what's going on in the hood. It never lies. I did a contract once for a company, and we couldn't figure out why certain policies weren't getting pushed out. And we realized after doing a ton of digging and slapping Wireshark on domain controllers, that in fact, when you have more than 25 controllers, it stops by default, and like you never would know, right? So that is a fantastic use of this tool. This won't be super high end. I was kind of tripped up by the fact that the way that they're doing the live streaming is I had originally thought I was going to do a lot of demos and run through demos on it, sort of how to do different things in Wireshark. But I guess the way that we're doing the live streaming for all the people that are watching online is that they're rolling the slides as I'm rolling them so that we can present it. So I've got a lot of snips of Wireshark. I want to talk about Wireshark, but we're not going to be doing that. Yeah, so I've been doing IT for a long time. I recognize a few people here. Being an IT nerd, I'm not necessarily always the best at names, but I used to work as a Microsoft certified trainer, and I became a ninja at doing certifications because any course you had to teach, you had to pass the exam for. So really good with that. I'm teach at SAIT. I've been there for a really long time. The other thing that I do, and this is kind of more of why I'm here actually today, I've been doing world skills for a long time. So it's sort of this biannual, that's every other year, right? Biannual. Every other year they do this world skills competition. So we do sort of a regional competition every year. And then every other year we do a national competition. And it was an IT networking system. There's lots of Linux, lots of Cisco, lots of Windows administration. And I did that for a long time. And, you know, the top kit in the country goes, we have these international competitions. And now what I'm doing for world skills, I'm the skills competition manager for cybersecurity. And one of the main reasons I'm here, but I want to see their CTF, and I would really strongly recommend if you guys have a chance. They do a great CTF here. If you have a chance to go in and go and play with it, it is a fantastic learning opportunity. And so my job to do with World Skills now involves putting on the CTF, which is way above my head technically. But I need to kind of organize it and find sponsors and find people who can build these things and talk about that. So if you're keen on CTF, look it up. Okay. Wireshark. Let's actually get down to a couple of brass tacks. Probably standing here. Can't see. Talk about Wireshark in terms of what it is. So what we call it's an analyzer. It's a network analyzer, a protocol analyzer. It will look at the bits as they stream down the wire, piece by piece as it comes along. When I say bit by bit, I mean it is each bit of the stream, not a little bit at any time. And it's very, very clever. It's really interesting to kind of look at it. When we start to play with it a little bit, and I found it even just trying to put the slides together for this, I started to get into sort of some interesting, sort of playing with some different things. And we'll have a look at that. You can run this thing in promiscuous mode, which basically means it will listen to everything that goes by, and you can pick up everything on the wire or wireless, medium, whatever the medium is. Great troubleshooting tool, great for people to look at that and figure out what is going on with things. Really learning and understanding kind of what's happening. So this is getting into that thought process that I was talking about. Like I think for IT support people or for security professionals or whatever, it's great to memorize the exams for a test and get that certification. Some of the bad parts are just open, but what's really critical is that you understand what's happening underneath. So when stuff starts to go wrong, you have an idea where to go and start with. So a little bit of history on this thing. It's been around for a really long time. 97 was what I found. And it's kind of gone through a bunch of things. When I first learned it was actually Ethereal. Sort of my first thing I looked at. Actually, I think the very first tool like this that I looked at, Microsoft used to have one, and maybe they even still do one called Network Monitor, a really old one, but all kind of the same. Essentially how they work is they have something called a dissector. And the dissector, what it will do is it will analyze the frame as it moves through, and it will look at this thing piece of the frame by piece of the frame. And I'll tell you what I mean by this in a second. 2006, rebranded, open source, widely available. You can get it. They now formed this Wireshark Foundation. So a couple of things about it. It is not magic, like everything in IT. It's not really magic, although it looks like magic sometimes. It is based around standards, and I've got a screenshot later, kind of looking at some of the RFC standards and comparing that to the output from it, just to give you an idea of how this thing kind of looks. Probably useful to sort of maybe talk about what it isn't. So this isn't a hacking tool. You wouldn't really use Wireshark on your network to figure out if somebody's having an attack, if somebody's attacking you, or to figure out to see, like what's sort of going on. You don't use it to modify its flight, right? There are other tools, there are other stuff for that. But it is really fantastic for looking at things, and if you grab captures and you can kind of go back and start to understand what's happening in the loop. So just as a reminder, just because we're going to be looking just sort of at some of this stuff, as stuff is traveling, wireless, wired, or whatever it is. In this case, it's wired, it's Ethernet. But you have a chunk of data that might be, say, it's a DNS query or whatever it is, and then that thing gets encapsulated, right? And I think I'm not sure where everybody's at technically here, so I'm just bit going. As that thing gets chunked up and passed up and down the TCP/IP stack, right? It'll have different headers that will get added to it, right? So there'll be transport header like TCP or UDP, there'll be an IP header for addressing. So if it's going to go off your network, do that. And then depending on what the media is, it'll have some kind of a header for this. And as stuff moves across network devices, it'll rip off parts of these headers, like a router or from wireless to wired or whatever it is. it'll reassemble these headers and with the data hopefully stays intact, right? And I think for everybody here, that's pretty on point. I think we can do that. So I do have some screenshots of it. We'll have a look at it. One of the things that I see quite a bit, well, I guess a few things about Wireshark is it's really noisy. Have I been doing this for a long time? Like I remember back in 10 days, 2 days or whatever, right? We're really, really slow and really unstable. Newer networks move a ton of data. They move very, very quickly. You would be quite astounded, maybe people on this room would be astounded, at the quantity of the crap that goes out to, I don't know, Microsoft, Google, all of those ad sourcing places. Like when you're on the internet, it's just constantly firing stuff all the time. And even if you do nothing else with Wireshark, fire it up and watch that sometime. It's quite illuminating. So yeah, basically you can pick an interface. The trick sometimes is to pick the correct interface. It can be pretty tricky sometimes if you've got sort of a multi-home system or if you've got multiple interfaces like Bluetooth or whatever, wireless, which one you have to make sure you get the right one. And then you can watch it real time, but what you find is this thing becomes quite unwatchable pretty quick. So my advice would be generally, if you're trying to get a good capture, install Wireshark on whatever system you want to grab the capture on. So like if you're trying to grab like something we'll look at here in a bit, Kerberos login from a client machine, throw it right on that machine, do it there. And then you can see the traffic go through, you can see the request and response come back, and it's really clean. The interface itself, I think, how many people are familiar with it? Look, I don't even need to be here. You guys should be talking about it. Interface is pretty straightforward, right? Toolbar along the top, standard, the view, all that kind of stuff, and the toolbar underneath. There's a filter bar so you can filter different sorts of types of traffic that are inside there. And typically then you'll have 3 panes. You can choose the view, whatever. You have the packet list, which will list off the packets in order. We'll look at all this stuff. That's the packet details. So any packet you're going to highlight, we'll take it up and we'll basically start to use these dissectors to have a look at that stuff. And then we will have which will show the actual bits. It does it in hex. So this is the status bar on the bottom for connected. So the whole thing looks like this. So all this stuff up and along the top, right? That's that top toolbar, packet list, packet details, and then you can stack this way or whatever, and the actual bits themselves. Pretty standard interface, stuff on the bottom, right? File, edit, view, go, capture along the top. So it's kind of got all that usual stuff that you sort of see with every one. Everybody put their hand up, but how much have you really used it? Lots. A little bit more. Here's kind of what I found doing this. It was really fun, actually. Sounds kind of weird, but it was like, so I'll show you some slides here in a minute. So I was like, okay, so I proposed this. Let's what should we look at? So I was like, okay, so what happens when you do an Nmap scan? Okay, where? How does it scan it? What port is it coming from? What order is it searching? And you don't know. I mean, you know what it does. But then when you slap Wireshark on it, you can start to get into it and actually see how it goes. And so I started, and I've kind of just scratched the surface. Just because of the way that we're doing this presentation with the rolling slides rather than this demo, that there's sort of a lot to see. So this is the packet listing, just in a little more. So you kind of get a bunch of things that are coming down here, right? These things will come in order, right? Always. And you can sort all these things by column, which is pretty awesome. So you can click on the column, or like, so if you highlight like ARP, it will alphabetically in that column. And so you can grab all the ARP packets together, or get IJP, whatever, DNS queries. So you can grab all that stuff and you can kind of see it. It's here. Yeah, so these are the sort of standard columns, right? So time, and you'll notice one thing that always astounds me, how quick. So thousandth of a second is how quick that stuff comes through. Source and destination, usually by IP. So we can kind of sort of track it. And then again, you can click on this one and sort these different things. Replace protocol, size. And usually what they'll have is they'll have some kind of breakdown in terms of some kind of Englishish description of what's basically going on inside that frame, which is pretty good. Yeah, fair enough. Thank you. The details pane. So this is where I wanted to kind of break into this a little bit more. The details pane has, once you've highlighted a particular packet, it will basically load that thing up and it'll start to evaluate this thing in a lot of detail. And so you've got all the different frames. And the reason I kind of showed you that earlier one was that, right, you've got the Ethernet frame on the top. In this particular case, we've got the IP header there as it comes in. It's UDP. In this particular case, what is it? It looks like an ARP frame. Or DNS, actually. DNS, yeah, so UDP. UDP and TCP for DNS. And then DNS is the actual data in this particular case, right? And all of these little arrows are drop down. You can break them open and it will show you bit by bit exactly what's going on. So just sort of as an example, IPv4. So it's showing it in this particular chunk of the header that we've opened up. The bits are actually 0100 for binary, and the header length 0101. So what I did is I grabbed the RFC for this, which kind of embarrassed, but I think is 796. Actually, for that number. When I did my master's, I took this course where with TCP/IP, I thought it was going to be like easy walkthrough course because I've been getting the full course, how to write a router program. I had never done anything. I'd never compiled anything. I've done weeks and weeks on it, reading and stupid trying to make it exactly, and we get this big hex dump of stuff. But so here's kind of what we've got in terms of and a dissector is somebody with a big head, sits down, and looks at these standards, and they will write it out, figure out, okay, well, what is happening with this? So then we've got the versions laid out to the first 4 bits. So this is actually coming 32-bit bytes, right, for the header. So 4 bytes, byte being 8 bytes. And the first 4 bits, right, is the version, and then it's IHL, which is the internet header line. So it basically does a description of what it is. In this case, it makes total sense. This is IPv4, so it's 4. And if it was 6, it would say 6. So 110. In this case, the header length is 0101, 5 in binary, basically saying if you read this, yeah, pretty standard. Beginning with data, 32-bit, minimum value header is 5. It basically is 20 bytes. So not bad, I guess. This is everything you see is so somebody has to sit down if they want to evaluate DNS traffic or any type of traffic at all, which is based around a protocol. Somebody will have developed this. So it's pretty interesting that the community has generally developed this stuff over time. And we can now use it to open this stuff up. Yeah. Attached bytes frames. So this basically shows a hex dump of this, right? So one of these is byte, right? So 4 bits and 4 bits. And so it's this in this particular case, this one is we open it up. Here's the center address. Here's gate 00. This is actually hex dump of that. It's totally. But it's kind of neat to see this. And quite often what you'll see here is a lot of gobbledygook. You can't read it. When it's clear text, it shows up. It's kind of fun. You see what is actually happening. Purpose of the talk, though, really isn't so much to talk about how to use Wireshark. Pretty tough to do that. but more just sort of a discussion around using it as a tool with utility, trying to learn what's happening in the use together to take it back by more of a mindset, really. Um, I'm about health. I have students come up with this. We just tell us the same thing. It might be it there. It seems really obvious. We've done a lot, but it isn't so much. And I think probably a lot of people here are like have to present like this. So like I wanted to demo, but I think we'll do this in slides, and I've got some good snips, some kind of fun stuff that I had. Start to see how the point. So one of the things that I did, I just built a little virtual network and took it off the internet, set that machine down, and so these guys weren't constant. As you see, Microsoft's always getting Google is always getting everybody's always just querying and then just like all of them. Shut that down. Not us getting mentioned. I kind of hope I like demo up there. I demo it. So I started to play it. So I talked about end map. So how's our end mapping? Everybody's probably done it. Look at it. Touched it. End map is a little bit confusing. I mean, it's really simple, but it's also like it's got like a like yeah, massive chunks. You start to play with it. So yeah, I just fired this thing up. I installed a couple of services on my server, and I ran a scan. So how do you think? I think that what order? What does it do when it gets a hit? So simple, right? So I just sort of thought, yeah, just play with a kind of a couple of things. One of the things I was also curious about was the timing templates. And I think you guys are familiar with timing templates. So -T, what is it? One is paranoid, I think, where it's super, super slow. And T5 is like fast. I think they call that insane, aggressive or something. So just kind of curious about, well, okay, so what does it? And here's kind of what I saw. So here was sort of the first thing. Here's our timing. Like, check how fast that is. So 16.5, it's, yeah, 2, 3, 4, 5, 6, 7, 8, 9. It's doing about 10 frames every 10,000 of a second. So it's quick. It's very, 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 very fast. Down here, I actually took the dog out for a walk, and I thought I'd stop the capture, and then I came home, and yeah, so that's why that's 49,000. But it's basically 15 seconds to the T5. And I guess the idea is if you're trying to avoid detection, right, you can go a lot slower. But that is just sort of, if I want to scan a machine, I'm going to get in there and I can do that. Gets the same. Actually, I didn't even get a result. Not at what I needed. What's the default? 10,000 points? Yeah. Maybe more than 1,000 because I'm looking at numbers here like, oh, yeah, this is the other concern, right? Just to read it off, 5810, then it scanned 1163 and 4899, 2105, 3269. So it's random. All of these are coming from port 34919. It's just a random not a non-well-known port. But we got a hit here because in this case, he came back. Right, so went 3269 here, and we've got a reply back here. The 3269 is, what is that? LDAP, I think. So this is a domain controller that it's scanning. It hits that machine, and eventually it got a reply back on that. So that port is open. 3268, 3269. Thank you. So I thought that was really interesting. So it just sort of randomly does this, and you can, and there's a million things you can do with it. Nmap is like every different type of like TCP scans, SYN scans, you name it. All sorts of really kind of super interesting stuff. And I found it was pretty fun. I soon started playing with all kinds of different stuff, and I didn't get captured with all of it just because it's too much. But I thought, okay, well, so what happens if we run like a script? So you guys know you can use Nmap in the community. They've developed the whole NSE or the Nmap scripting engine, and there's a bunch of scripts that will run to do all kinds of different tasks. So I just grabbed a pretty common one. And, this is a Windows machine, so SMB, num should enumerate the users that exist on it. It's going to try. It's going to fail. It's a 2022 server. It's just out of the box. But still, I thought it was interesting to look at what was sort of going on. And really what I found was that it did a really, really standard, it does the scan. But when it goes ahead and it runs the script, it basically does this in order. It does the scanning first, and eventually gets down to doing the scripting. And when the scripting starts, what it will do then is, in this case, whoever wrote the script basically used really standard utilities, MBT stat, which old like me, that they've got we used to do rings and all that kind of stuff. We used to have to worry about that. But let me just see. So here's it's doing a negotiate protocol request. So it's basically trying to figure out, okay, well, what version of SMB are we going to use for NetBIOS? What are we going to use? And it's come back, and it comes back a couple of times, and it basically runs this membership query, and it's just really, really standard. It's a query against basically an NBT that dash. N is your local, and dash A would basically do a query against that particular machine, whatever the machine name is. And that's basically exactly what it's done. So I just sort of found that sequence kind of interesting because I've run lots of scripts before in Nmap, just to sort of see, whatever the challenge is, to try to pull information out. That, yeah, basically these guys have just written pretty standard open script that will run. It'll do the scan first, and then it will basically run this thing, whatever it is, the stat scripts trying to do in one time. It'll also do those things in order. I started playing around with some stuff. So one of the cool things about Wireshark and doing Nmap. So if you download Nmap and you want to install it on Windows, then no problem, you can do that. It comes with a really awesome interface. Just because we were talking about it, I just sort of thought, I don't know if you guys have done that or it's just straight up command line. I learned my first computer use these. I couldn't afford the really expensive Zenith Easy PC that had the 20 meg hard drive in it. So I got the one with the 2 floppies. So I learned computers from the command line. And so for me, that's not bad, but I find a lot of people now have never really worked with it, and they find reading a man page or a help page or whatever, end of the world, lightning is going to strike, we're going to die. When you install Nmap on Windows, it comes with this utility called ZenMap, which maybe you're familiar with, I don't know. And it's a really nice GUI interface. You can run create these profiles, and what it will do is it will what type of scan do you want to do, and it will pull these things out, and it will build the text scan exactly how you're supposed to do that query and run it. So it's a great way to learn it. So if you want to start to learn all the different options and all the different switches and things you can put in there, I would highly recommend it. It's a really useful way to start to do that. Nmap, of course, it's also part, like if you want to, one of the things that it's cool when you run the center for Windows is this utility called Netcat, which I think probably a lot of people heard of. Being a Unixy kind of guy. Netcat is built into every version of Linux or Unix. When you install ZenMap in Windows, you also get Netcat on Windows. Now, Netcat also is part of something like Kali, and you can then, as part of an attack, you can load something like Netcat. But one of the first things that I ever saw or ever learned about doing was setting up bind and reverse bind shells. You guys know what I'm talking about? Let's first say that. Yes, get at least 2 or 3 thumbs up or big head nod. So I sort of thought, well, let's take a look at that. We slap Wireshark and do a bind shell. What do you actually see? So yeah, the idea with this thing is you can use Netcat to make essentially a straight socket connection between two computers. That's really all it is. It's just a straight up connection directly from one computer to the other computer. It's the world's most boring chat, because you can type something and show up on the other screen, and that's all it does. But there's a lot of other utilities that you can do with it as well. One of the things that you can do is you can bind an application one side or the other side. So there's this bind or reverse bind. So if it's like a reverse bind and somebody comes in and makes a connection to it, you can bind it to an application like, oh, I don't know, cmd.exe. And effectively what you'll get is when you've connected from Linux or from the other machine, you will get the command line on that machine. And God help them if you happen to be connected to the person who's logged in as administrator, right? I think in Richard Mitnick, Kevin Mitnick, in his book in that Ghost in the Wires, gave a pretty hilarious account on it. He was trying to get in, and he was talking to some woman. He'd been fired from his place, but he's trying to get in and get access to some files or something. And she was asking him for help because he was the only one that knew. And he basically told her to set up this Netcat listener, and he was able to connect in and build an account for himself. Yeah, Metasploit does this as well. So like you can set up bind, reverse bind, and if you get into like the interpreter shells and things like that inside there, you can do that. A lot of phishing links use this. I had one just the other day where you connect up to this weird, stupid link, and I would hope most people in here would not have an issue with that. But when you click on it, essentially what it's doing is it's going to create this reverse bind back to your machine, and then you can set them in and through your firewall. They can get access to it. But if we do a capture of it, it's kind of interesting. So basically, you know, pretty handy. I logged into the administrator. We don't have to make these things too hard. But yeah, so that was the top command there. So that -E option basically is saying I want to do it. And I opened up port 5446 in this particular case. I opened up a firewall rule, which no one would have blocked it, but of course there's ways that we could have got around it. And basically it just sits there and it just listens. It's just waiting for something to make a connection on that port. And so you do that. So I went ahead and I made the connection from the Cali machine. But eventually, yeah, it says, oh yeah, host name lookup failed. But eventually, yeah, that pops right there. And you get that command. And of course, because really likes hacking, build myself an account, add it into the domain admins, and sure enough, no problem. Right? So good cautionary tale of why to never log in as administrator, because then you will have the right to the person on the far side. What does the capture of that look like? So the capture didn't really show me a ton. Some stuff, it'll start off and it's running. You can see it's doing a SYN-ACK. So any TCP session always will do the SYN-ACK. So it will try to synchronize. It will acknowledge that from the other side, because computers have no idea if when they send a message, then just got to get these acknowledgements going back and forth. And then it will come back with a second acknowledgement. So it set that up. So that even of itself is kind of interesting. So you can see I'm connecting from the first computer to that particular port. The reply comes back, going the opposite direction. Yeah, the text description there really isn't too enlightening. If you look at the data that starts to come through here, it's not that clear. Kind of exactly what you see. But what I sort of thought was pretty interesting, when you look at the data bytes, you can start to see this. It's not so clear, but once it starts to actually read these characters as ASCII characters, it starts to pop up, and you can see that clear as anything. And what you have the ability to do in Wireshark, and it's pretty interesting. If you look at it, hold on, it's hard to see. If you right click on it, follow screen. Basically pull all of that information together, put it in one pane. You can kind of read all the output through it. And so when I did that, this is exactly what it showed. It showed exactly all the text things that had flown through there, and it came across the wire, and you could see the actual commands as they were coming across the wire. So that's not super crazy to me. Netcat you can get. There's different versions. CryptCat, I think, is one you can do. But I would say that your standard, a lot of defense sort of things should hopefully wave a flag. A command like net user add /domain comes across. Maybe somebody is thinking, hey, there's something going on there. But you can actually, set up an SSL connection, and then it will encrypt that traffic, and so you can't get it. Which is also true of all this stuff. If it gets encrypted, the data that you'll see that comes across, you can't really read it, right? But when it comes through, it's pretty good. I fired up Ettercap. I don't know if we're familiar with Ettercap. Ettercaps. It's man-in-the-middle attack. Real simple, and you can do different types. You can do it with SSL, without SSL. And basically the way that like a lot of attacks work, it's based on the fact that when the bearded hippie guys that wrote the internet in California in 1969 or whatever were coming up with these protocols, they had no idea that maybe security might be an issue someday. All this information traveling back and forth. So when they wrote the ARP protocol, there's no authentication, there's no encryption, there's no verification of the data, there's no anything. So here we go. You can see we've got a whole whack of ARP frames. And essentially, initially, the attacker, in this case, this is my attacker, FBAA. He fires up and he sends a couple of ARP frames out and says, hey, who out there has 1/100? Who out there has 1.254? And the reason I picked those two machines is I want to jump in the middle of this conversation. 254 is the gate. So ideally, as an attacker, what I want to start to do is I want to tell that client that my MAC address is really the MAC address at the gateway. And vice versa, I want to tell the gateway that my MAC address is the MAC address for this machine, which happens to be the main controller. So then what it starts to do is it just starts vomiting out information. And it just basically keeps sending these out broadcasts. And even though nobody's asked for them, it just starts firing out and saying, hey, here's my MAC address. Here's an ARP frame. Here's my MAC address. Here's my MAC address. And he replaces the IP address of his IP address with the target IP address. But he keeps throwing out his MAC address. And the way ARP works is it'll just cache it because they were really trusting in the early 70s, late 60s. And so these machines will just cache it. It should make things go faster. Right? You don't have to do an ARP broadcast every single time, so it's quicker and easier. What I thought was kind of interesting is when I did this, captured that, no problem, really clear and easy. You can see who the attacker is and who the attacker isn't. But it did actually flag it, which I thought was kind of cool. So it's basically showing that there's a duplicate IP address for that address. So it actually caught that, but it didn't sort of do anything. Sure. I don't think anybody on the line can hear it, but that's fine. You have to give it. So what you can pick specific IPs to do it. What it can do is it can do like a broadcast on the network, find all the stuff, and then you can pick targets, and you can specify what those targets should be. So yeah. But yeah, so I kind of thought that was pretty interesting, and that's pretty good. So then what will happen is when the client is going to the internet, it'll forward it to the attacker, and the attacker forwards it to the gateway, and then the gateway replies back from wherever it is. It goes through again. And the same idea can work. It's really, really hard to do now. It used to be pretty easy, but what you can do is you can basically create a self-signed certificate on the attacker. Client will come to you, give you its certificate, and then it will pass its certificate off as you, and go out. It's much, much harder to do that now than it used to be. So what are we at for time? Just about there. So we'll try to do this quick. Here's what I found out about Kerberos. It's like the cloud. Nobody knows how it works. Nobody. I talked to people who know a lot about this. Nobody had the right answers. Everybody kind of knows. Like, I would put myself solidly here, so hopefully I don't go way technically in the wrong spot. Nobody understands it, not exactly. So, okay, so it's tickets. Used to be, back in the day, if I wanted to authenticate in a Microsoft network, we use Manager. And LAN Manager would go out, and if I was going to log in, I would say, here I am, I want to log in. Server would send me back a challenge with this thing called a node, which was supposed to randomize it. And then I would type in my password and use this nonce to encrypt it, except if somebody's listening on the wire, they would pick it all up. Challenge and the nonce. And then when I replied, they could pull that information out. It's really easy to get the hash of my password. And then you can run it against password cracker. So that was really weak, especially the way that Microsoft used to do the hashing. Right? They used the LM hashing, which was terrible. So it was really, really easy to pull it. So they basically started to use Kerberos. The idea with Kerberos, Active Directory uses it. We can do Kerberos realms in Linux. Same kind of a deal, but it's tickets. So now we'll have a ticket. So instead of ever throwing my password across the network, I will have a ticket, and I can use this ticket. But the trick is okay. So how do we authenticate? Really, passwords never sent to wire. But here's the deal: part of the ticket is going to be encrypted with my password. And so if the server sends it to me and I want to be able to use it, I need to be able to decrypt it, which means I have to have it. So really, it's like a shared secret. Like when you set up a Wi-Fi router, you want to connect to the Wi-Fi, you have to put in the password, you've also put the password in the router, and if they match, you're good. Same idea with Kerberos. So if you think about the process when you build a user account in Active Directory, you put in the user, all the stuff, you put in the user's password, maybe you click that little box that says password must be changed to first login. And I found this process really interesting. I started to talk to people about, okay, so what happens there? I get that part, no problem. This part's great. So ticket goes, nobody came up after the right answer. So essentially what we have in Active Directory, we got the KDC, lives on the domain controller. Really, there's two things inside there. There's this authentication service, and there's this ticket service. So there's sort of two things that are going to live inside there. So we should be able to see this. And so if we grab a capture of this, we should be able to see the request and reply back to the authentication service, and we'll have this TTS exchange. And again, we should see the request and reply. And we can get that pretty clear with Wireshark. And then what we'll get is if I ever want to go out, I will have this ticket, and I want to get access to a resource like a printer or a share or something. I'll then take the ticket that I've been given from this ticket granting service and say, hey, I should be able to get access to this, and I will get another ticket. Tickets all over the place. So my question was this that I started to ask people. Okay, so great, I get this part, I think, mostly. What happens when the user changes in password? Everybody's eyes just went, oh, wait a second. Because surely that password's got to go across the network, right? So how do you get that? We'll get pretty tight on something. So let's just try to wrap this up. So when a client logs in, you should get an authentication request and reply. And they'll get this ticket granting ticket, and then it'll use this service. But here's kind of what I got. And this was fascinating. I talked to lots of people. Nobody could tell me how that password got sent securely. Turns out it depends. That's the right answer. And so I wound up doing a lot of reading. This is kind of the thought process that I kind of wanted to explore a little bit. Because once we start to get into it, you start to play with it and more, and you start to grab more captures and you start to do it. So you can see at the very top, I've got the request and reply, the authentication service. So it needs to authenticate the user. First thing it's going to have to do is do this TGS request because the user needs to be able to get access to its own computer. Am I allowed to access this resource? So it'll get that. And you can see that there's a whole bunch of these TGS requests and replies coming back and forth. One of the things that I kind of wanted to show you was this guy. This Kerberos TGT, this ticket granting ticket. And I kind of had this idea that maybe we could have a look at golden ticket or what that looks like. But here's what I'm doing, because I think I'm going to run out of time. Homework. How do you about homework? you can build one of these things pretty easily. It's pretty fascinating to jump on there and you can grab this. So I've got this Kerberos ticket granting ticket, but that's sort of not enough. If you want to do a golden ticket attack, you need just sort of a couple of things that you can do. What do you need? Domain name, SID of the domain. You need this account. This is the thing that really kind of makes it work. I don't have a password for that. If you actually want to do a password change, so how's a password change? Let's maybe just stick with that. That's all I got time for. If we're going to do password change, I have to send my password. I have to go in, control delete, the option to change password. Clearly, that thing has to be sent across the network, and Kerberos isn't supposed to do that. So I talked to lots of people, had all kinds of good answers, good guesses, but it turned out, including me, nobody was right. What it turned out, the actual answer is it totally depends how you change that user password. If you do it from the command line, you do one thing. If you're doing it from the client and you do Control-Alt-Delete, go change password, it does a certain thing. If you do it from the domain controller, it actually does something different. So it totally depends which of these processes kind of go there. In our case, because I did it from the client, this is option 3, and that isn't too eliminating either. I had to go read up on that. But basically, there's this K password is essentially what it would do, which is a request and a reply. And I just sort of thought this was kind of interesting. I grabbed it just because it did illuminate it. So essentially, in this particular standard, what it will do is it'll actually set up an AES tunnel between the client and server, AES 256. So it'll set this thing up, and the hash of the password is the thing that will be sent between the two machines. I had all kinds of answers on it. So anyway, all right, I think we're probably at about time. Fun to try to do. Mimikatz or in Metasploit, you can do those golden ticket attacks. But yeah, so I guess really what I was trying to bring across was just having maybe a different attitude about stuff, not to just sort of memorize answers, but to try to get a handle on what's happening. I think that's all I got.